Hi everyone, this is Mrs. Scott, and today we're going to be answering the question, what are congruent segments? So as we get into this, we need to discuss first what a postulate is. We're going to be learning two postulates. And a postulate is just a rule that we accept or that is accepted without proof. So it's something that's pretty clear to see, and you just assume that it's true without anyone actually telling you, hey, this is why it's true. All right, so that's the first thing. So our first postulate is called the ruler postulate, and if you've ever measured anything with a ruler, you've used this postulate. And it just tells you that you can use numbers to represent where a point is. So if you've ever used a ruler or if you have ever plotted points on a graph, you've used the ruler postulate. So for example, if we had on a line points A and point B, and point A was at 1 centimeter and then point B was at 6 centimeters, the fact that we are able to put numbers to represent where those are would tell us that we're using the ruler postulate. Now, those numbers, 1 centimeter and 6 centimeter, are actually the coordinates. And the coordinate is the number that corresponds with a point. So when you plot a point on a graph, for example, the ordered pair 1, 2 would tell you where that is. So it's the number that corresponds to a point. And lastly, the distance, which if we talk about this segment AB, the distance is just the capital letters AB is the difference between those two coordinates. So in this case, if we took the absolute value of 1 minus 6, that would give us the absolute value of -5, so the distance of those two would be 5. All right. So now let's practice using a ruler. So get a ruler handy for our first two examples. We're going to be measuring segment JK to the nearest tenth of a centimeter. So on a ruler, the centimeters are the shorter or the smaller units than the inches. So we're going to line up our ruler so that the first tick mark is right at the center of point J. And we're going to count over until we get to K. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then these little tick marks are 0.1, 2, 3, 4 centimeters. Okay, and then in example 2, we're going to just simply flip over and use the inches side. So I'm going to go ahead and erase these numbers so I don't get confused. And now we'll use the inches. And inches are in 16ths. So these small tick marks are 16ths, and then the next are eighths, the next are quarters, and then halves. So if we look here, we're starting at 0, and then we have 1 inch, 2, 3, 4. And then these tick marks here are eighths. So I have 1, 2, 3, 4, 5, 6, 7 eighths. So to inches, it's 4 and 7/8 inches. Okay. If you need any help with that, just come find me and I can clarify that a little bit more with you. So our second postulate in today's lesson is the segment addition postulate. And that just tells you, say you have a segment AC. And if you have a point B between A and C, that tells you if you add up the length of segment AB and the length of segment BC, that's going to give you the length of segment AC. And that makes sense. Say this was 1 centimeter and this was 2 centimeters. Well, you would know that AC, the whole thing then, is 3 centimeters. So it's pretty obvious. All right, now let's use that postulate to do an example here. Here they tell us on the map below, it appears that Milwaukee, Oshkosh, and Wausau lie approximately in a straight line. So if we look at these 3 cities, I'd agree with that. Those look like they're about in a straight line there. If Milwaukee and Wausau are 188.1 miles apart, so these are 188.1 miles apart, and Oshkosh and Wausau, so from Oshkosh to Wausau, is 102.9 miles apart. How many miles apart are Oshkosh and Milwaukee? So we are trying to find this distance. Well, we know that these segments have to add up to 188.1. So if we do 188.1 minus 102.9, let's borrow here, we get 85.2 miles would have to be that distance there. And notice if you add 102.9 and 85.2, you would end up with this 188.1 miles. So this right here would be the distance from Oshkosh to Milwaukee. Okay, so now we're going to look at a problem that has a few segments here. And they tell us that A, B, C, D are collinear, and then points C, X, Y, and Z are also collinear. And they also tell us some important information here. The first thing they tell us is that AB, BC, CX, and YZ are all equal length. And notice I put these little marks on each of those segments. Those mean that they are congruent or that they are the same length. They give us some more information. They tell us that AD, this whole segment on the top here, is 54. XY from here to here is 22. And XZ is 33. So that's all the given information. Now, I like to do this. I like to fill out the entire diagram before I go and answer these 6 questions here. So the first thing I notice is that this segment XZ, if that whole thing is 33 units long, and from X to Y is 22, from Y to Z has to be 11. Well, if YZ is 11, AB is 11, BC is 11, and CX is 11, because they're all the same. Okay, so now I know that from A to C is 22, this whole thing from A to D is 54. So if I subtract 54 minus 22, I end up with 32 units for CD. So now I know each and every piece. Let's go back and answer these questions. First of all, AB, that was from A to B, we know is 11. From B to D would be 32 plus 11, or 43. From C to Y would be 11 plus 22, which is 33. CD we already found is 32. XC, or CX, it doesn't matter what order you write those letters in, is 11. And lastly, CZ would be 11 plus 33, which is 44 units. Okay, so you do have a couple problems like that on your assignment today. Let me know if you have any questions on those. There's also a QR code you can scan for additional examples to help you out. All right, our next topic, I've used this term already in today's lesson. Congruent segments are simply segments with equal lengths. So if we think about that previous example, these 4 segments are congruent because they all had a length of 11. All right, so here we are going to use the segment addition postulate because we know that from A to B and then from B to C, if we add those lengths up, that has to be the length of the whole thing from A to C. And let's fill in these expressions that they give us. They tell us AB is 14 units long, so we'll replace that with 14. They tell us BC is 3x minus 4 units long, so we'll replace that with that expression. And then we have that AC is 4x plus 4 units long. And now we're going to use some algebra skills to find the value of x. So first let's combine like terms. We have 3x plus 10 equals 4x plus 4. Let's subtract 3x from both sides. These cancel then, and we end up with 10 equals 4x minus 3x is 1x, or just x. And lastly, if we subtract 4 from both sides, we end up with 6 equals x. Now I know it's really tempting to circle that and say you're done, you found the value of x, but our question is saying find the length of BC. So what we have to do is plug into that expression 3x minus 4 and replace x with 6. So 3 times 6 is 18 minus 4 tells us that BC is 14 units long. Okay. Now for these last 2 examples, I'm going to give you links, 2 links on how to copy a segment and then another short video on how to bisect a segment.